All right, here's our second video from section 7.1. We just got done talking about what a function is. We looked at a couple different examples. Now let's talk about how to determine if something is a function by either looking at its graph or its equation. If you remember from example number 1, they gave us a couple different ordered pairs. And it says here that we can express that as a function by graphing it. If you look at the 3 dots on the graph, every x goes to only one y. Every x only goes to one y. Every x only goes to one y. So those 3 points together would be considered a function. So how can we tell if we're given a graph if something is a function or not? Well, one easy way to do that is what's called the vertical line test. If it's possible for a vertical line to cross the graph more than once, then we say that the graph is not a function. So if your vertical line only touches it once, then we say it is a function. Look at these 4 examples. If you look at this first one, we call it a parabola. No matter how I draw that vertical line, doesn't that vertical line only ever touch the graph once? So we would say that this is a function. For every x, there's only one y value. Look at the second one. If I draw a vertical line along this graph, no matter how I draw that vertical line, it looks like it only touches it once, so that would be another example of a function. But look at the last 2. If I were to draw a vertical line on this sideways parabola, at x equals 2, isn't there 2 different y values that correspond to x equals 2? And so my vertical line touches more than once. This would be a non-function. Same idea with the circle. If I were to draw a vertical line on this circle, doesn't it happen to touch it twice right here? And so this would be another example of a non-function. So it's easy to tell when you have a graph if it's a function by just quickly doing the vertical line test. If it only touches once, then it's a function. All right, what happens if we get a little harder though? What happens if I take your graph away and I only give you the equation of the graph and you had no idea what it looked like? Well, if you're not really sure what it looks like, we can always do a t-chart and kind of plot some points to kind of get a good idea of its behavior, and then we can kind of figure out from there, from the behavior and the graph, the sketch of the graph, if it's a function or not. If you look at this first one, y equals x squared plus 1. We've talked about those before, right? The x squared means it's a quadratic. If you're not sure what it looks like, what you could do is do a t-chart. Pick some x values, plug them into your equation, and then see what your y values are. So when x is 0, 0 squared is 0, plus 1 is 1. If x is 1, 1 squared is 1, plus 1 is 2. If I plug in a 2, 2 squared is 4, 4 plus 1 is 5. If I plug in a negative 1, negative 1 squared, negative 1 times negative 1 is 1, 1 plus 1 is 2. If I plug in a negative 2, well, negative 2 squared is positive 4 plus 1 is 5. And then what I can do, after I have a couple of different points, is I can start to plot these points. I can plot the point 0, 1, I can plot the point 1, 2, 2, 5, negative 1, 2, and negative 2, 5. And so my graph's kind of sloppy, but it looks something like this. And so I know that if I draw a vertical line on this graph, no matter where I draw that vertical line test is only going to touch it once. So this would be an example of a function. Any quadratic is actually a function. So anytime you see an x squared, we know that it's going to be a function. Whether it opens up or down, that vertical line is still only going to touch that graph once. All right, what about b? Y equals 2x plus 1. There is no x squared, there's just a single x, right? X to the first power. And this might look familiar to you if you've ever seen y equals mx plus b. Yeah, this is actually an equation of a line. It's a linear equation. But if you're not sure, again, you can always do a table of values, pick some x values, plug them in, and see what y values you get as your output, your domain, and your range. If I plug in a 0, you should get 1. If you plug in a 1, you should get 3. If you plug in a 2, you should get 5. If you plug in a negative 1, you should get negative 1. And if you plug in a negative 2, you should get negative 3. After plotting all of those different points, kind of a rough sketch of your graph, it should look like a line, right? A y equals mx plus b. You've got a y-intercept of 1 and a slope of 2. If you remembered that from a previous class, you can always graph that really quickly. If that's a line, and I go to draw a vertical line, no matter where I draw a vertical line, isn't it always only going to touch it once? If you put in one x into your equation, you're always just going to end up getting one y value out. So this is another example of a function. All right, what about c? If I have y equals the absolute value of x minus 2. This is an absolute value graph. If you're not sure what it looks like, again, do a table of values. Plug in 1, plug in 0, plug in -1, plug in 2, plug in -2, and see what your outputs are. If you plug in 1x, don't you always just get out a different y value? When you graph it, an absolute value graph kind of looks like a V. Remember, where an x squared, a quadratic, looks like a U, a parabola, an absolute value graph looks like a V. But no matter where you draw that vertical line, it's always going to only touch once. So this is another example of a function. You plug in 1x, you'll always just get 1y out. So these are 3 different examples of functions. Quadratics are always functions, linears are always functions, absolute values are functions.